Section 2.3 is about temperature. So the SI unit of temperature is Kelvin, which is represented by a capital K. And you don't have to put a degrees, like the little circle in front of it. The definition of temperature is it's a measure of the movement of atoms in a substance. So it's the kinetic energy that the atoms have. So if the atoms aren't moving very much and they're pretty still, the temperature is going to be lower. As you add heat into your system or energy, the temperature will rise and the atoms will move about more. And it is measured in degrees. There are 3 different temperature scales that we're going to talk about here. So the first one's a Kelvin scale, which is the SI scale, and the equation for that. And Kelvin is used a lot. It's not used for measurement necessarily so much, but it is used in a lot of equations. So we do have to convert from Kelvin to Celsius, but it is pretty simple. So to convert from Kelvin to Celsius, all you have to do is add 273.15. So most of the temperatures that we experience around us are around like 290 to 373 Kelvin or so. That's kind of like ambient temperatures around us. 298 Kelvin is about ambient, like room temperature. Absolute zero is defined as 0 degrees Kelvin, and that means that there is no molecular motion, that the molecules have no motion, they're not vibrating or moving at all, and it's never actually been achieved. Like they've never been able to get anything cold enough to be at 0 degrees Kelvin. In fact, they don't know what would happen if they did get that. Because there's always like some small motion or vibration of the atoms that keep it from getting all the way down to 0. They've gotten really close. They've gotten to like 0.01 or something like that Kelvin, but they've never actually gotten to 0 degrees Kelvin. So nothing should be negative Kelvin because it doesn't make any sense. So Celsius is what we use most. Most of the world uses Celsius for their temperature scale. So Celsius is nice because at 0 degrees Celsius, water freezes at 1 atmosphere, and at 100 degrees Celsius, water boils at sea level. So that's a nice range. Most things happen within 0 to 100 degrees Celsius on every day. But we use Fahrenheit, right? So the news reports the temperature in Fahrenheit. I'm sure your car does. Even our thermostats use Fahrenheit. So to convert from Celsius to Fahrenheit, you have to use this equation because it's not a 1-to-1 change. Like one degree of Fahrenheit change does not equal 1 degree of Celsius. So that's why you have to use that ratio. Because water freezes at 32 degrees and then it boils at 212 degrees Fahrenheit. But we are not going to use that in the lab. We're actually going to try and do all of our measurements in Celsius. The only reason you should have to use this equation is if somehow you mess up in the lab and you record your temperature in Fahrenheit, then you would have to convert it. So we are going to be using Celsius for the most part, unless we have an equation where you have to use Kelvin, and we will be doing that once we get to gas laws further on, and there are 2 videos that you should watch along with this section.